This is going to be a tutorial for the FRC 2021 season with changing the motor controller or number of motors that you have on your drivetrain within the LabVIEW programming for FRC. So we're going to start with the FRC RoboRio project template, which we can get to right here. And we're going to give it a title. Evidently they didn't change the year, so we're going to change the year to 2021 and save it in a place. I just put it in my robotics with my other robotics files. And we want to select a completely empty folder. So we have to create that folder first and then open it and select it. And put in, I'm on team 8069, 8069. For now, we're just going to stay with the arcade drive template. Finish. And here we go. We already have the team number in here. I'm going to go ahead and open robot main. Control E. Open up begin. Control E. And expand this a little bit. And we're gonna be doing some work in here, so I'm just gonna make some room. Now this is what they start us out with. This is using two Victor SPX motor controllers via PWM. So this is not with a CAN. And they give us this open 2-motor VI. Now, if we were to accidentally delete that and or we just need like 4 motors, we end up going in here to, so I right click, WPI Robotics Library, Robot Drive, and I'll pin that for now. So we don't see this open 2 motors VI or an open 4 motors VI like there was in previous years. But we do see a open motors VI. Now when we place this on the block diagram, it actually turns into a whole bunch of code. Now, this actually has the safety config in it, so I'm going to get rid of this. And we'll go ahead and get rid of this. And here we go. So this is when we drop the open motors VI, this actually gives defaults to a 4 Spark motor controllers. And we could select PWM 0, 1, 2, 3. And remember, these are PWM, also not the CAN network. Now, what is this code actually doing? So this is an array of 4 elements. And then this is a for loop that goes through each one of those elements. So PWM 0, false, PWM 1, false, etc. and opens up a Spark motor controller for each one. Now, there's actually a different way that this can be represented. So I'm going to show that. So I'm just going to disconnect this for now. And go get the open VI, just like this one. And I'm going to make 4 copies of this. I'm going to hold down Shift and Control to copy and make things go straight up and down. And then we can right-click on the PWM channel 0. Actually, I'm going to make this a little bit easier. Oops. Okay, we just need a build array function from the array palette. Build array. To do this routing, I'm just doing single click, single click, single click. Okay, now this code, this right here, does the exact same thing, basically, as when we had this code attached to this. This is just condensing it using the for loop and this array here. Now, I'm going to just undo a bunch of things and demonstrate something else. Okay, with this setup, we just have to do 2 clicks to use any other type of motor controller with PWM. We can go from Spark to Victor SPX or Talon SR or whatever you want in here. Now, if you want to use the CAN network, we have to do a few things. First, of course, you have to have the proper third-party library installed, and then go in here, and we're going to do the Talon SRX, and we're going to use this open Talon open and delete this VI. So I'm just going to select that and then do backspace or delete. Clean up these wires a bit. Drag this in. Select the motor address. There we go. Now that may look perfectly fine. However, that even the run arrow looks good. However, the data type of this PWM is not the same data type that is supposed to go into this Talon Open VI, and we can see that by pressing the yellow question mark for context help, and then hovering over the Open VI, and we get some details about it. Actually, that doesn't show us exactly what I was looking for, but if I hover over this wire, it is a motor address, PWM, blah, blah, blah. Notice that little red dot. It's really hard to see, but it's called I believe it's called a cohesion dot, and it automatically changes the data type. If we delete this wire and hover over the terminal of the Talon SRX, we can see down here that it is that the type is unsigned byte. It's an 8-bit integer representing a value between 0 and 255. Whereas this PWM value, it is an unsigned byte, also 8-bit integer, 0 to 255, but it's called an enum, which gives it the drop-down functionality. So actually that may in fact work, but to be proper we should delete it from here. I'm going to come right back to that. I want to show something else about this array. Looking at this right now, we can technically not tell that there's 4 elements in it. If we drag this down to expand it, we can see these are grayed out. I could actually make these invalid too, but they're not grayed out. So now I can see that there's exactly 4 elements in here because these are grayed out. Now, what's this number up here? This is actually the index. So if we increase it, it just scrolls us down. And first index is 0. In fact, if we right-click on here and choose Visible Items, Vertical Scroll Bar, and collapse this a bunch, we actually have a scroll bar right here. And when you change the scroll bar, it changes the index. So the scroll bar and this index are really equivalent. Whenever you change the scroll bar or the index, you're not actually changing the value in here, you're just changing how you're looking at it. And hovering over the index, really the whole array thing, we can see the data type in the array. So the array is a one-dimensional array of a cluster, and in that cluster there is the PWM enum and a Boolean indicating if the motor should be inverted or not. Now we want to change this, coming back to what we were talking about earlier, we want to change this PWM to just a normal unsigned byte without the integer. So we're going to delete it. So I'm just going to left click, just get that, left click the edge of the PWM enum, and only it gets selected. And then backspace. Make that a little bigger again, and I'm going to right-click this device number, create constant, delete that wire, and drag this in here. Now this looks good, looks perfectly fine, but if we hover over this, the inverted Boolean actually comes first. So how do we fix that? We can right-click on the cluster. Be careful how you select the edge of the cluster. And then reorder controls in cluster. Notice how this is index 0 and, element 0 and element 1 inside the cluster. This is different than the index of the array that we were talking about earlier. So I'm going to select this as element 0 and element 1. And then press the check mark. And now, if we look at context help, after I hover over this again, so this refreshes, I see that the device number, the unsigned 8 data type, and inverted, those are in the proper order. And actually, if we want, I can still drag this around in here, but if I want to force it to show the right order, I can right-click the cluster carefully, go to Auto Sizing, Arrange horizontally, and then they will snap into place. Actually, I can't move those around anymore. Okay, we just have to connect this wire. And that should be good for a Talon SRX via CAN. Oh, we probably need to change these numbers. Now, if you only have 2 motors and 2 motor controllers for your drive system, then you need to make it so that more of these are grayed out. So to do that, you select one of the clusters. You gotta be real careful about selecting that. And right-click on it. And then go to Data Operations, Delete Element. So now we just have 3. And then do the same thing. Delete. And now we're just down to 2 motor controllers that are Talon SRX over CAN. And this first one is going to be on the left and then the right. And if you had more than 2, you have left and right. And if you even have up to 6, left and right. And you can do, I don't think anyone has that many motors on their drivetrains yet. Let me know if I'm wrong. But actually, there is one more, at least one more, but one more way of working with the CAN motor controllers. So, and that would be to, this time I'm not going to use the for loop, so I'm just going to delete some code. Just hitting the wrong key there for a second. Get rid of the for loop, but keep that open. I'm just going to right click the for loop, remove for loop. Okay. Create these. And so if you have just 2 motor controllers for your drivetrain, this is similar to what we talked about earlier. Just do the build array function. Wire these up. That's good for just 2 motor controllers. But if you have more, you can use this follow VI. And let's say you have, get rid of this now. Looking at my reference picture. Oh, so we actually need some more open VIs. So I'm going to do like that. From here to here, this top terminal, be careful to get that top terminal. And bring up context help again. So the second terminal is the master motor controller for this side. Do basically the same thing down here, and we'll say this is the master for that. So now we can do, say, 0, and we'll do this different. ID 1 for the left, ID 2 also for the left, ID 3 and 4 for the right. And that should work. Actually, technically, I'm not sure how if you're supposed to use these RefNum registry set VIs so that references get closed and finished, but I don't think that's going to be much of a problem. You might end up with a memory leak if you stop and restart your program over and over while you're programming, but it won't affect you on the field for sure, because the finished VI actually never runs when you're on the field.